All right, so let's start 2.5, equations of lines in linear models. Okay? So like I said, right now we're going to learn a couple more ways to find the equation of a line and also, graph it as well. Okay, so the first equation we're going to learn is something called the point-slope form. Okay, or the formula of the point-slope form is given a point, so x1 and y1, and a slope. We can find the equation of the line using this equation here. So it's not just enough just to graph it, what is the actual line itself, right? When it comes to, so what was the original one without using the graphing portion? And it's going to be y minus y1 is equal to m times x minus x1. Now notice this y here and this x here, we actually don't put numbers in. These are the numbers we're going to plug in our point to. That's the ones with x1, that's the y1 value, okay? And then all we're going to do is solve for y. So in other words, we're going to solve for this value here, okay? Meaning we're going to distribute and then just subtract it over or add it over depending on what we have, okay? And it's pretty straightforward, right? Here's an example illustrating this one. So let's find the equation of the line given the point 6, 3 and the slope of 2. So this is our x1 and this is our y1. And all we're going to do is plug it in respectively where we're supposed to be. So there's just y minus the y value, which is 3, is equal to m, which is 2. And in parentheses, x, we leave that blank, minus x1, 6. And now we just distribute. So we distribute here, distribute there. So we get this. And then last step is just add 3 to both sides. And there's our equation, just like that. Okay. Now, again, before we do some examples on that, the reason why we want to write it like this is because this is also called a very special form. It's called the slope-intersect form. Okay, and it's the equation, or it's the most popular equation when it comes to graphing lines, is because you get a lot of it when it comes to it. So in other words, this is another way we're going to learn how to graph lines using the slope and something called the y-intercept, like we talked about last section. Okay, now given this type of equation, like this one here, we can find the slope and the y-intercept just by looking at the number in front of x and the value on the outside. So our slope, in the example here, was 2, is the exact same number as the one in front of x. And that is not a coincidence. That's the reason why. So if I just give it to you like this, you can find the slope automatically just by looking at the number in front of the x. Okay? And the y-intercept is, again, always in the form 0, b when we want to graph it. So that b term is the value there. So again, if we go on this example, for instance, and asked you what is the slope and y-intercept, so the slope would just be 2, because that's the number in front of x, and the y-intercept will be 0, the last number, in this case, -9, and that will be your y-intercept. And then from there, you can graph it. So that's an alternative way to graph lines when it comes to it. So a little recap, right? We talked about t-charts. We talked about x and y-intercepts, finding those and just plotted them. We also talked about now finding the slope. So using the point and just rising over running, right? Giving a point and its slope. And same thing here. Now given the y-intercept and the slope to solve for it as well. So there's multiple ways to graph lines. Again, whatever you feel more comfortable is the way you want to go by doing it. But again, right, all we're showing you is different ways to do it. That way, if you like one comfortable than the other, you're a-okay to do that as well. Okay? But again, the most simplest one you'll see is this way, because that's usually how a line is going to be looked at when it comes to it. And then again, that gives you the slope automatically and the y-intercept, and you can just plot the point and use your slope when it comes to it. Okay? So let's do some practice problems with this. So we flip the page. So let's do some different scenarios. Finding the equation of a line given a couple of scenarios, okay? So let's say, for example, the first one is we want to find it when the slope is, let's say, 2/3, and our point is 4, I don't know, let's say 6 for fun. So very similar to the example we just did on the last one. Okay? So this is our x1, this is our y1, this is our m. And again, all we're going to do is plug it into our formula. Okay. So it's going to be y minus y1. So in this case, y minus 6 is equal to m, and in parentheses, x minus x1. Okay. So our slope, x minus 4. It'd be nice if this focuses. Yeah, there you go. And now we just distribute. So we distribute here, distribute there. So this is 2 over 3x, and this is going to be 8 over 3. Okay. And then just add 6 to both sides. Add 6. And like I said at the very beginning, right, you're online, so take advantage. So what I mean by that is, let's figure out what this is. So negative 8 over 3 is that. And then we're going to be adding 6 to this. So 3.33 plus 3.33. And there is our line, right? Never be afraid of fractions. So again, if I asked you, what's a slope? Well, notice the same slope. What's the y-intercept? 0, 3.33. Questions on our first example at all? Good, good. Okay. All right. Now let's suppose we had this. Same thing, we want to find the equation of the line, now just given 2 points. So a little different scenario than we have here. Okay. Now this is going to be the longest of the scenarios you'll see because we don't have a slope. So we can't use this equation right off the bat. So guess what? The first thing we have to do is find the slope. So this is x1, y1, x2, y2. So it's going to be 2 minus 1 over 5 minus 2. That's 1 over 3 as our slope. Now, since we have a slope and we have a point, now we can go back to our equation we just learned previously. Now, the cool thing is you can pick either one to get our point. It doesn't matter because you're going to get the same answer either case. So since I already have this x1 and y1, I'm going to use this as my point, and that is my slope for this equation we just did previously. Okay. So again, it's going to be y minus y1 is equal to our slope, which we just got, x minus x1, which is 2. And again, we just simplify. Okay, just like last time, add 1. And let's see what we get. So same thing. And then we're adding 1, so 0.33. So that is our line right there. And again, if I asked you what's the y-intercept, it'd be 0, 0.33, because you already know what the slope is, because we had to do it, right? It's 1/3, 1/3. Again, this is the most lengthiest to do because we have to do one extra step, right? First find the slope, and then we follow our example there. Questions at all there? No? Okay. So now let me show you the easiest of the scenarios you'll see. Same thing, we want to find the equation of line given a slope and the point. Now, the reason why I say this is the simplest of them, if you can recognize this, that is your y-intercept, 0, comma b. So remember, whenever you have a point that's 0, comma b, or 0, comma number, that's your y-intercept. Meaning, you don't have to do any math, you just plug in each other the numbers respectively are supposed to be. So, in other words, all I'm going to do is plug in the m, which is 5x, plus the b term, which is just 8. And look at that. Voila. But let's suppose you didn't recognize that. Well, it's okay. You just keep doing the same thing. So y minus 8 equals 5, and then parentheses x minus 0. Again, if you want, you could distribute. And then 5 times 0 is just 0, right? So there's nothing there. Add 8 to both sides. And you get that. And there, so either way, you get the same answer. It just recognize it and just go a little faster. But again, using the same equation, you get the same answer in either case, right? So it's just, a couple of different ways to deal with it when it comes to that. Okay. So, any questions at all? Finding the equation of a line using our new point slope formula. So either given a slope and a point, just like this example, or given 2 points. We first have to find the slope and then use it. And same scenario, given a slope and a point, and just plug in and chug in. Again, this is the most difficult you'll see because you have to do one extra step to get there. So no questions there? Okay. All right. The second to that thing we want to talk about is, again, vertical and horizontal lines. So again, I just want to quickly run down. Here are horizontal. Here are vertical. Okay. So just to quickly run down what we had previously, right? This one had no x-intercepts, and we had a slope equaling to 0. This one had no y-intercept, and we had a slope that is undefined. And now we're finally going to add on the last major thing of horizontal vertical lines. Equations. So the equation of a vertical line is always of the form y equals a. And the opposite for horizontal. Horizontal is y equals b. So there's no y equals ax plus b. It's just x equals this or y equals that. So it's a single number. So whenever you see y equals 5 and asks you to graph it, you know it's going to be a horizontal line at the 5. If you see an equation that says x equals 4, negative 4, therefore at negative 4 on the x, it's going to go up and down automatically. Okay. So a quick little example if you guys want to know. Let's suppose we want to graph these two. So since the first one says y equals negative 3, we know it's going to be a horizontal line. And how you do this is, well, if it's on the horizontal, you're only going to go up and down the y. So go down to negative 3, which is down here. So here's negative 3. And you can make a horizontal line going straight across. And that's how you graph it. And same thing applies over here. So if you have x equals 4, you know that's a vertical line at that value. So on the x scale now, you're going to go to positive 4. So 1, 2, 3, 4. And then just going to go up and down. And there you go. Any questions there at all? So everybody comfortable? Anybody alive? Just kidding. Just joking. Sometimes I wonder. Okay, cool. All right. Last concept before to finish up this this section. Parallel and perpendicular lines. Okay, so parallel lines. So everybody's seen parallel lines. You guys have driving. They're lines that never cross, right? Just like lines on a freeway. Just go straight lines that go across, the diagonal ones. Perpendicular lines are intersections, right? They're like cross like that, like a T when it comes to it. Okay, so the difference between the question is, well, if I'm given a line, how do I find another line that's also parallel? Or how do I find another line that's also perpendicular to what I have? Okay, and it all goes back to two very special concepts. For parallel lines, so again, like I said, they never cross, and the biggest thing is they have the same slope to one another. So you know two lines are parallel if they have the exact same slopes. An example of that would be this. So these two lines are parallel because they have the exact same slope. It doesn't matter about the y-intercept, right? According to the definition, just have to have the same slope. Perpendicular is a little different. When it comes to perpendicular lines, again, they cross like a T, so at 90-degree angles. Now, the biggest thing is their slopes are opposite reciprocals of each other. Okay. Now, what in the world does that mean? So first, they have opposite sign. So instead of positive, now it's a negative. Instead of a negative, now it's a positive. And you flip it all the way around. So these are parallel. And this is an example of perpendicular. So notice, one's positive, one's negative. That's the first check. And reciprocal means you just flip the entire fraction around. So now the 2's on top and the 1's on the bottom. So these are perpendicular. So again, it doesn't matter what these numbers are. All you're looking for is the slopes, is what tells you. So how will this come into play? Okay. So let's suppose we have this line here. Okay. And let's suppose we're also given the point that one there. Okay. Let's say A, we want to find a parallel line to this one going through that point. Okay. So remember, we want to find a line that's parallel to this. Okay. Well, so if you go back over here, we need a couple things, right? So in other words, we have to use this equation to find the line. So we need a point, which we have, and we need to find a slope. So the point is given to us, which is right here. Well, we got to find the slope, m. But it says it is the same. So therefore, it has to be the same as this line here. And we know the slope is exactly the number in front of the x. So that's -2/3. And there we go. So now it just goes back to a question like this. Given a slope and a point, go ahead and find the line. So let's do that. So now we're going to be y minus, again, this is x1, y1. So 3, our slope, x minus 0. Okay. Bring it over. And this is our parallel line. Just like that.
We could have also just noticed that the point was 0,3 and done that other symbol.
Oh, yeah. Yeah, I didn't even notice that. Yeah, that's exactly right. Yeah. Nice catch. Well, if it wasn't, you would have to do that. But yeah, nice catch. It was actually that. I didn't mean it to be that way, but good catch. Yeah. Okay. So any other questions? All right, so let's go B. Let's find that's parallel. Perpendicular to this line now. Same scenario. Okay, so again, we're still giving that point, but now we got to find our slope. Well, again, we got to do a little bit more work because it's a little different, right? So first, it's opposite sign. So instead of negative, now it's going to be a positive. And we flip the entire fraction around. So now it's 3/2 as our slope. Okay. And then we just do the same process. So let's suppose that wasn't a 0, right? You have to do this process. So you can see, the work behind it. And there you go. So this is a perpendicular line. Okay. Any questions there at all? No? Everybody comfortable with that? Not too bad? All right, let's just try one more to give you guys more practice. All right, so we're going to follow the same process we did here, right? So let's do the easiest of the two, parallel, right? That's the easier one of the two. So we're given a point. So this is our x1, y1. And our slope, in this case, well, if we look at it, 5. Beautiful, right? It comes to it. And now we're just going to plug it in our equation. So y minus 2 is equal to 5 times x minus 3. This then we have to distribute, right? Because it's not the y-intercept. And then add 2 to both sides. And there we go. So 5x minus 13 is our parallel line. All right, so the next one, let's find our perpendicular line. So again, first thing I do is find a slope. Now, this is a trick question, right? It's a whole number. So what I do suggest when you come before you get the slope is put this over 1, because any number, you can put it over 1 to make it a fraction. And that's why it's a trick question. So here it's positive, so we know it's going to be negative. And now if I swap places, it's now going to be 1 over 5 as our slope. So again, if you ever have a whole number, just put over 1 and then just swap places, right? Then you can flip it around to get to 1/5 or the 1 whatever number it is in front. And then again, we just plug it in. So it'll be y minus 2 is equal now negative 1/5 times x minus 3. Okay, distributing this. Minus and minus makes positive. And then adding 2. Again, if you're not sure, use a calculator, right? Plus 2, 2.6. Voila, and then you're done. So, any questions on this example at all?
Where does the -4 go, if at all, anywhere?
Doesn't do anything to the problem. That's the thing. That's why. So when it comes to finding parallel and perpendicular, this has nothing to do with anything. Yeah, just like these ones. So you really just care about the slopes when it comes to it.
Right, because it could be any other. All right, thank you.
Exactly. This could have been 5 billion, and these two would still be it when it comes to it. Yeah. Yeah. So I could have done this like this. And you still would have gotten these two lines. This number doesn't affect it at all. Any other questions? Okay, so before we go finish up this section, there's one last example I want to give you guys. Is what if I say this? So what if I ask you find the slope and y-intercept of this? Then you may think, well, first of all, whenever you want to find the y-intercept and the slope, you want to convert it to this form here. So in other words, that's what we have to do it this way. Or in other words, we want to just solve for y. So again, going back to solving situations, right? So first thing we're going to do is get rid of this because we want this by itself. So we're going to subtract 3x to both sides. And these are unlike terms, right? So you just treat them just like unlike terms. And then lastly, divide everything by 4. And there you go. We converted it to that form. And now here we could find our slope, which is -3/4, and our y-intercept, which is 0,4, right? Because that's the number there. So for your homework, let me see if I can show you your homework here.